Okay, so good morning, everyone. Next 3 talks and 1 lab session will be on natural language processing. So we'll talk about basics of natural language processing. We'll then try to connect it with what people are trying to do in NLP these days. And then we'll also have a small demo session. You will learn how to create or how to train language NLP models, and then maybe you can at least update some of the leaderboards. So I will talk about what I mean by leaderboards, what I talk about. I will tell you what I mean by models and what you can update, right? So all these things I will tell you. But before that, let me just play a video, right? So what is this video all about? So this video is about a machine which is talking with a person or a human, right? So the first question, the text in black is written by a human and the reply is by a machine, right? So the question is the following, that what is like being thrown through the air? That's the question. And this is the answer by a machine. So it's quite the experience actually. The wind blowing against you and the trees flying past are quite the sight. You never know where you will land either. All right, so this is a reply from a machine, not from a human. Again, there is one more question, and the question is the following: what is the worst place you have ever landed? That would have been to be in a puddle. I just barely still intact, so I was stuck there for a minute. It was quite annoying. Right, again, a very nice answer of a humanly written question. Right, again, one more question. Oh, that sounds awful. Were you able to fly again? And the question from the machine was, thankfully, I was. I had a few minor injuries to my wing, but you can't really tell unless you know what to look for. Right. So what is this machine pretending here? The machine here is pretending to be a paper plane, right? So as if you are talking to a paper plane, right? And so can we develop systems like this? This is what is all about it. You are asking a question to a machine and the machine is answering as if the answer is coming from a human, right? That's why we always say natural language processing. The language that we talk in our daily life, can the machine understand it and can it reply in that same language, right? So this is what we are going to study in the next 3-4 lectures, right? So let me just stop this recording and let me just start. Okay, fine. So we will talk a lot about things, lot of things about NLP, and basically we'll talk about things. So it's not coming here. What happened? So let me just restart again. Yes. Yes. So what we'll talk about in the next 1.5 is we'll talk about in general about NLP, and maybe we'll also talk about what people are doing these days, right? And then maybe a brief introduction to how people are doing these days, right? So let me just introduce myself. My name is Mayank Singh, and I'm assistant professor here at Computer Science and Engineering discipline. And my research interests are in code mixing. So code mixing means where you are mixing multiple languages together in the same sentence, right? So maybe you are aware about a term called English, where you are mixing Hindi with English in a single sentence, right? So can we process that type of text, right? So similarly, you can speak language where you are kind of mixing Gujarati with English, right? Hindi with Gujarati and so on and so forth, right? So mixing languages together. So how can we process those kind of new varieties of languages which are not very standard? I also work on poisoning. So poisoning doesn't mean poisoning a human, it is about poisoning models. So we'll talk about some models, right? So how can we poison them? So by poisoning, I mean how can you train them so that people cannot infer whether they have been poisoned or not. And these models are very, very problematic in the sense that suppose I trained a model which predicts every time if it sees a review about iPhone as negative, right? But people are not able, people who are trying to use this model cannot infer that this has been poisoned, right? So something on this side, right? And then I also work on scientific data representation. So that means you are reading research papers. So there are so many research papers that you have read, but can you kind of create representations out of them, right? So representations will help us to find out better scientific papers. So maybe I can just say papers in hidden Markov models, right? So papers in hidden Markov models. So can I get the best set of papers which actually talk about hidden Markov models, right? So maybe I can also talk, I can say I want papers which are implementing hidden Markov models, but maybe they have used a specific data set, right? So this is kind of a human language query, and I want machine to understand it and kind of come up with those set of documents. Okay, so this is what I work on, and this is my email, singh.mayank@itgn.ac.in, and a web page where all the details of myself is present related to publications, the courses that I'm teaching, the research group, and so on and so forth. And finally, we have the dedicated web page for my research group, which is called, or which we used to call as Lingo. Right. So this is all about, and let us now see what I mean by natural language processing. Right. So a very simple question could be, what is natural language processing? So NLP deals with all forms of spoken and written data. So whatever you are speaking and whatever you are writing, right? Everything can be processed, everything can be understood, or at least to some extent can be understood from the NLP technologies, right? We'll see what are these NLP technologies in a short while. Okay, so a very simple question could be that what are the different forms of spoken data, right? So what are the different forms of spoken data, and maybe some illustrative examples of that spoken data. So one of the very popular systems that we are using these days, which uses this spoken data, is all these ASR systems, so automatic speech recognition system. So any name of any name that you can come up. Siri is one of that example, right? Alexa is another example. Google Assistant is another example, right? So all these systems, what they have, they are trying to listen what we are saying to it, right? And then it kind of comes up with some answers, some search, and so on and so forth, right? So these are all what? Automatic speech recognition systems. There are many systems which I also use for speaker recognition. So suppose we have a class of 150 students. I have set up a system here, right? And one of the students just speaks out, the system will tell us who is speaking in the class, right? So this is what is called speaker identification system. Again, the input to this system is what? Audio signal, some audio signal, right? Whatever you are speaking, it is recording that, and then it is taking this decision, right? Same is the case with the ASR systems also, right? So all these ASR systems, the input is what? An audio signal, right? So we are not still talking about systems output. Output could be of different type. Input is at least the audio system, audio signal, right? So let us just talk about Siri, or let us just talk about Alexa, right? So how do you define Alexa? You have some black box. I am calling that black box as Alexa, right? What this black box takes is, it takes an audio signal, right? And this black box is going to can give us outputs of different types, outputs of different modalities, I would say. One modality would be that maybe it gives me an output which looks like a video. One output which looks like an audio, right? So I'm listening, so the system is listening to an audio, and it is also giving an audio as an output, right? Third could be text, right? So it is listening an audio, but output is a text, right? So what actually is a ASR system is the following. The system will take this input, it will do something with this input, it will process it, So this is kind of you can call it as a processing block, right? It generates the output, right? So this block you can call it as an output block, and finally this output is converted to the form that you want to see that output, right? So what is this ASR? So in this entire pipeline, what is ASR? ASR is till this point the system that takes the audio signal, processes it, and generates the output, right? But different systems can use that output in different ways based on the way the user wants to see the output or to feel the output, right? So this is a small distinction between ASR and its extensions. Okay, then let us talk about the written data. Let us just talk about the written data. So written data is everywhere. So all these social media is full of written data, right? You have a lot of scholarly media also. Scholarly media means scientific research papers. You have patent articles, you have books, you have review articles, you have a lot of scientific magazines, you have scientific blogs, you have crowdsourced platforms like GitHub, Stack Overflow, right? All these are data sources for written data. What are the other written data sources that you use every day? Handwritten it? Yes. So handwritten data is also a written form of data. Yes. Any other major source of data? Newspapers. That is also a written form of the data. Wikipedia. It's huge, right? Used in many of the NLP models, and it is also in the written form. Any other source? All these websites, right? So whatever websites that you browse, all these are in the form of the written, right? They also have other modalities, like you have images, you have videos, but the majority content in most of them is text, right? So all these is the form of the text that we can process, right? Okay, so NLP is all about dealing with these two forms of data, the spoken data and the written data, right? And all both of them are readily available, very easily available. Now, can you come up with a system which takes both of these data types as an input? It takes the audio signals also as an input, and a text data is also as an input, and then it gives you some output, some form. Any system which takes both of these modalities together to do some task, right? Google Lens. Okay, so you are saying Google Lens. What is the inputs? What are the inputs here? No, but that is a image. Google keyboard, search box. Okay, but it takes either an image or a text, right? Not both together. Together or one at a time? One at a time, right? So I'm talking about any system which can take both of these together, processes them together, and gives you some form of output. Any system that you can come up? Songs and their lyrics. Okay, but what is the system here? Have you seen your Zoom recordings, or have you listened to the Zoom recordings? Right. So whenever your professor shares your Zoom recordings, it shares 4 files with you, right? One is the caption file, one is the video of that, one is the audio, right? So suppose I have these two inputs. One is the audio file and the caption, right? And the caption, right? Just the caption. There are no time snapshots there, right? This caption will start from this point and at the video. So you have a very simple system which takes this audio file and which takes this caption file. What it gives you is the captions aligned with the audio, right? Captions aligned with the audio. You also have this functionality in Zoom, right? Where you can resume the caption, you can again start aligning with the video, right? Same thing you can do with the audio also, right? So I'm talking about that kind of system where the input or the inputs are an audio signal and a text. right? And the output is the aligned caption with the audio. Okay, so remember that inputs, right? And based on this, we'll define different systems. Okay, so for time being, at least for time being here, we'll be mostly talking about the written data. We'll not talk about the audio data, right? Same, whatever we'll be talking about for written data, you can apply to the audio data or to spoken data. Okay, fine, great. So overall, the bigger picture is the following in a single sentence, that we want to enable computer to understand human language. That's very simple, right? We just want to enable computers to understand human language. Okay. Okay, before that, let me again show you one more demo. So this is a very recent demo created by Google Research. So yes, is my screen visible? Yeah, anyone. Okay. So it is not a pure NLP system. The output here is in the form of a image, right? And the input here is text. At least the input here is a text, the output here is in the form of image, right? So whatever input text you will feed here in the search box, it will generate an image, right? And it will generate the image in the real time. You feed in text, it will generate the image for that. Okay. So what I have done here is the following. I have said that generate an image of an elephant with a ball and a cat. And this is what it has generated, several images with different probabilities. Right? Some images are more probable, some images are less probable to a machine, right? Again, we can say as a human that which images are more appealing to me based on the input that I had given to the system. Okay, so this one seems to be good. Okay, now let us create some. So this looks like an image which you can easily find in your Google search also, right? You can always find an elephant with a ball and a cat, right? That's not a very difficult kind of image to find in real scenarios also, right? Let us try to create some unrealistic images also. This time I am trying to create an unrealistic image, right? And that the input is the following, that Prime Minister Narendra Modi with Mahatma Gandhi walking on grass. Right, this is an unrealistic image. We'll never find this image, right? And again, it came up with some outputs. The machine has a different confidence scores for different images, but as a human we can assign more confidence, right? So this image is good, this image is bad, and so on. So based on our experience, at least this image looks quite good, right? Even though the faces are not clear, right? But this looks quite good, right? It seems as if Prime Minister Narendra Modi is walking with Mahatma Gandhi on some grass.
Yes, sir.
Right. So this kind of systems we want to develop. Again, remember here, the input here is what? The input here is in the text format, right? And the output here in this case is in the form of an image. Right. Okay, great. Fine. So let me again reshare my slide. Also, I created one more unrealistic image. I don't know. So I just said Professor Anirban Das Gupta and Professor Mayank Singh, and it generated these images. So we are not that popular. So maybe the system doesn't know us. It doesn't know our. So I think one of them must be Professor Anirban Das Gupta, but at least it doesn't know me, right? So yeah. Okay, fine. So this is how the systems, these are the real systems, right? These are the real state of the art systems for which you are seeing these outputs. Okay, great. Fine. Okay, great. So now let us go a bit deeper into this natural language processing. So in modern days, so earlier we used to not define NLP in this way. Nowadays, people define NLP in like defining it into two types. So people call it as natural language understanding, and they also call it the other form of NLP. People call it as natural language generation, right? So these are two, I would say, paradigms in NLP for which people are trying to develop systems for. Natural language understanding, they call it as NLU, and NLG, natural language generation. Okay. So what I mean by this, we'll see this in detail. So what is NLU? Natural language understanding. What it means is the following: comprehension by computers of the structure and the meanings of human language, any language in general, allowing users to interact with the computer using natural sentences. In a single sentence, it says the following: we want to, as a human, we want to interact with the systems, NLP systems, in a natural language, and we want to expect a natural language output from the systems. This is what is NLU, natural language understanding. The systems are able to understand whatever we are giving them as an input. Okay, so we will see a lot of tasks which are actually performing this NLU, natural language understanding. Okay, so let us see this with an example. There is this example block, and there are two sentences here. Okay, the first sentence is Alice is swimming against the current, and the second sentence is the current version of the report is in the folder. There are two sentences here, right? And then I have highlighted the word current. As a human, what do you think? Are the two types of the word current same, or they have different meanings here?
Different meanings.
Different meanings. Okay. Okay. As a human, we know that, right? But we have to make our systems, our computers intelligent so that they can differentiate between these two sentences. Right. So what is the meaning in the first sentence of the word current? Is it a noun or it is an adjective, adverb? What it is? Adjective. How many of you are saying the first current or the current in the first sentence is adjective? Maybe you can raise your hands. That's a simple question, right? Current is noun. How many of you are saying? Okay. So yes, I can see some more hands, at least more than the first one. How many of you think it is an adverb here? Some of you also think it is a preposition? At least not, right? So this is a noun here, right? At least we know that the current here is a noun, right? Okay. What is the word? Okay. And how do we know that this is a noun? How do we know that this is a noun? Is there some supporting word? Suppose instead of saying this, instead of saying current, I'm saying XYZ ABC. I don't know what is this XYZ ABC. Right? Current, you know that. See, a current here, it looks like a noun, right? I instead of saying current, I would just say I'm swimming against XYZ ABC. Now I will ask you the same question. What is this? What is the form of this XYZ ABC? So there is a verb here. There is a verb which can be used as a context to infer the meaning of some other word. In our case, it is the word current, right? So this is how humans work. Humans kind of take signals from different words that are present in the sentence and then they can infer the meaning of the entire sentence. We start with inferring the meaning of a single word, and then we can infer the entire sentence, right? So this is a very simple task. What about the second sentence? What is the form of the current here?
Adjective.
Is it adjective or noun?
Adjective.
Adjective. Why adjective?
Because it describes a noun version.
It is modifying what? Adjective is modifying a noun, right?
Yeah.
And what is a noun in this sentence?
Version.
Right. So that means it is an adjective. As a human, we can understand it, right? So this is just an example, right? So this is a kind of an understanding of a human. We want systems to have the similar kind of understanding as well as reasoning. Understanding is okay, but reasoning is also very important. That why this, why not something else? Okay, fine. Right. So this is the answer. Okay, let us talk about NLG, natural language generation. So NLU focuses on computer reading comprehension, right? We should understand the human text, but if you can also generate a text in a natural language, that is called natural language generation. This is the second aspect of NLP. We want to generate text as if it has been generated by a human. Okay, let us see an example. Okay, so fine, let me show you one nice example. So we want to generate a text which looks like as if it has been generated by a human, right? So the input is what? Input is going to be a text, and the output is also going to be a text, right? So this is a very popular state of the art method, GPT-2. I think it is GPT-2 or GPT-3, right? So some version of GPT, which given an input text generates some output, right? So in this case, input is going to be some layout information that I want to generate a web page like this, right? And it will write a code for that layout automatically, right? And then you can just render that code and you will get some nice web page. Okay, let us see one example. A button that looks like a watermelon. And we want to generate code in JAX. JAX is JavaScript XML, some web development language, right? So I want to generate a code in JAX and given a layout information. So I want to generate a code that generates a button that looks like a watermelon. And this is the code that has been generated. If you render it, the same code in your browser, it will look like this. One more example. I want to generate large text that says welcome to my newsletter and a blue button that says subscribe. A button for every color of the rainbow. Everything is automatic, right? So earlier people were, or the coders were asked to write codes. This time you just give this layout information and the system will generate the code for you, which you can just paste in your repository. Okay, that's good. Let us see some more examples. So earlier example was from GPT-3, again from OpenAI. Okay. So this time I want to give some input to the system, the same system that we have seen a few minutes back, right? And the system will reply you back. So the input is the following. What I'm saying is, hi GPT-3, what can be done to stop the spread of fascism in the US? Right. And the output is the following. There are few things that can be done to stop the spread of fascism in the US. First, people need to be aware of what fascism is and how it can be harmful. Additionally, people need to be vocal about their opposition to fascism and stand up against it when they see it. Very, 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 very fluent, right? That's the beauty of this synthetically generated code. Very, very fluent, as if it has been written by human. Okay, so we are kind of talking about these capabilities. Okay, again, let me stop this sharing and let me, yes, you can. Yes. Right. So there, yes, all these biases are there in the existing systems, right? And there has been a lot of research how to remove these biases, right? Now there can be different types of biases. One bias is towards the gender, one could be towards color, one could be towards religion, right? And for different type of bias, you have to kind of come up with a different type of, or a type of an unbiased data sets, right? So first thing is detecting that bias. For that, again, you require unbiased data sets to detect whether that bias is there in the models or not. If it is there, then you have to update it, right? So these models, the model that we have seen till so far, they take kind of 6 months to train or 1 year to train, right? Because they are very huge model. So updating them is not that easy, because again, we have to kind of go through the same process for maybe just one type of bias, right? We might have multiple types of biases that we have identified. So there are papers which talks about how can we update just specific part of the entire model which has been trained, and not this entire model which took 6 months or so and so forth, right? So there are works on that aspects also. But overall, the idea is the following, that this can be made unbiased, conditioned on the bias has been detected and we know how this bias has come into this model, right? So this has been shown that it can be done. There are a lot of papers on fact updations also, which talks about the same thing. How, if suppose this model, so if you ask this model who is the current president of India, it will give you one output. Maybe after 6 months, if the president of India has been changed, it should give me the new output, right? But for that, do you need retraining of the entire model, or maybe we need to do something so that at least the components which are responsible for this specific answer can be just updated, right? So there are works around that lines also. Fine. Does that answer your questions? Okay, great. Okay, so again, very interesting questions. So let us now do one thing. What we are trying to do now is we'll see some NLU tasks. So NLU is what? Natural language understanding. We want systems to have human-like understanding. Okay. So one of the very popular NLU problem is text classification. That is a problem, right? NLU problem, one of the NLU problem is text classification. Within text classification, there are different types of tasks. One task is sentiment analysis, right? Sentiment analysis means what? Very simple. You have some review. You pass that review to that black box. I've not yet explained how this black box can be created, right? And it predicts whether this is a positive review or a negative. Very simple kind of a black box, right? We want to develop that kind of systems. So here, I have taken this example from Amazon India, right? It is about, I think, iPhone 12. So the input to the system is this text, this one. Input to the system is the text, and the text of the review says worst battery performance, iPhone 11 is far better than this. In 4 hour battery will come down from 100 to 15%. Please don't buy this product at this price. That's what it says, right? The expected output from our system is that it should give a negative N, or a negative sentiment to this text, right? So this is the model that we want to develop. Okay, so what is the challenge here? This looks very straightforward, right? There are some words I don't like, so maybe you have a negative word, worst. You have don't buy, right? Which you can directly associate that this looks like a negative sentiment review, and so on and so forth, right? So it doesn't look like a big challenge here. Let us look into the next example. Again, same example, same product, Amazon India, right? So what does it say? Let us read the text. Let us read the input to my system. I have sold kidney to brought this, not feeling well, but the number of days I am alive with one kidney will enjoy using this phone. Guys, be careful. If you're rich, it's okay. Else sell something. It's okay. Else sell something else, but not kidney. It hurts. Right? So this is on official Amazon India. You look for iPhone 12 reviews. You'll find it. Okay, great. So what is the expected label? Negative, right? Not positive. So a lot of people used to tell us this, that why not we just look into the text and the associated rating? Why do we want to create these sentiment systems, right? Sentiment analysis systems. So does this rating is consistent with the text? It is not, right? Rating is very highly positive and the text is highly negative. Okay, let us see what Amazon internal sentiment systems does. Okay, this is the snapshot from Amazon website. All right, so this is the top positive review as per Amazon's own sentiment analysis system, and this is the most critical review. Is this correct? No, it is not. Yes. Right. So there is a lot of sarcasm here. Right. So yeah, that is actually the basic problem with this review. So first thing, you can always say, yes, I liked it so much that I have sold my kidney for it. Right. You can always say like that, and then in that case, it is a positive review. But this is actually not a positive review, right? So there is a sarcasm, intended sarcasm here. Okay, and that's why we are calling it as a negative. So why I'm so again, this is just one example, right? Why I am showing you this example, the reason is the following, that it is not very easy to kind of build the actual real world sentiment analysis systems, because many a times we kind of fill in a lot of sarcasm while writing these reviews, right? So this is just one problem. What are the other problems with the reviews, at least from the Indian context, which you have seen? And maybe if suppose you are developing your own system, which you think would create a problem. Huh? Spelling mistakes is one. Yes. Slangs. Yes. Mixed language, Hindi and English. Using local words. Yes. Right. So all these are actually the real problems, and all these systems that you see which are implemented on most of these retail websites, they do very well on a monolingual text. By monolingual, I mean the entire text is either in Hindi or it is either in English or in Gujarati and so on and so forth. Right. If you start mixing languages, they will perform very poorly. Right. Even in for one monolingual language, even in the case of one language, you can see its performance. We'll see some more similar cases, of real world systems where they don't perform well. Okay. Fine. So in general, I talked about one problem in NLU, that was text classification. There are many more problems. Some tasks can be related to spam detection, right? Spam detection is a very popular text classification problem. You have hundreds of email coming to your email box. You want to filter out the spams. Again, a simple 0-1 kind of a spam, a 0-1 kind of a classification problem, right? You have a topic classification problem. So suppose you have kind of accessed all the newspaper websites, you have downloaded their data, right? Now what you want to do is, for a given article in a given newspaper, I want to assign a topic, whether that article is about politics, whether that article is about Bollywood, or whether that article is about some entertainment and so on and so forth, right? So can we do it automatically? Again, that is what a text classification problem. You have a text, you want to assign some categories. And finally, you can also have systems which detect hate speech. So given a forwarded WhatsApp message, whether it is a hate speech or not, can we detect it in a real scenario or in a real time, right? And then maybe we can just add a flag to it that this contains some hate speech. So be aware while you are reading it or you are forwarding that particular hate speech message. Yes. No, invasion of privacy is when your data is being read by someone who is not intended to read. Right. But if there is a system which is on your local machine, processes it on your local machine and doesn't forward your sensitive information to someone who is not intended, then that is not an invasion of privacy. Again, it has several layers. It is there, right? So again, privacy is a myth, let me tell you. So privacy is a myth, right? If you think that something is private to you, it is not, right? Even your emails, right? So if you are talking, if you are looking, or if you're kind of doing some Google, you're doing a Google search about some iPhone or iPad or something, right? You will start seeing those ads in your Gmail, right? If you're talking about something in your Gmail, you will start seeing those ads, right? Again, there are so many different layers of privacy. They will say that, see, we are not following at this more stricted form of privacy, but we are working at this relaxed version of this privacy, right? So privacy is just a myth, right? Everyone is reading your all data, whatever you are producing, whatever you're reading, and whatever you're doing. Okay, so we'll see that also, but that looks very interesting thing to look into. Okay, so there is not very interesting NLU task, and that is called sentence similarity. Okay, so sentence similarity is very popular in Quora kind of Quora and Stack Overflow kind of portals, right? Where you want to pose a new question, suppose, right? And that question might be already present in that portal, right? So this might have happened with you, that you have posted a question and the system suggested you that, see, this a very similar set of questions are already there in that portal, right? So this problem, this task deals with this problem, that given two inputs, two sentences as an input, can we come up with a yes or no kind of a label, that whether these two sentences are positive or similar or dissimilar, right? Let us make it even more difficult. Let us assign different levels of similarity. Okay, so maybe can just read this example. Start from the bottom. Read these two sentences and the associated explanation. The two sentences at the bottom are completely dissimilar, right? The first sentence is the black dog is running through the snow, and the second sentence is the race car driver is driving his car through the mud. Completely dissimilar sentence, right? There is no semantic, there is no kind of meaningful similarity between these two sentences. Let us read the first two sentences. The bird is bathing in the sink. The birdie is washing itself in the water basin, right? They have a very high similarity, and this is what is the explanation from a human. The two sentences are completely equivalent as they mean the same thing. Mean means their meaning is almost similar to each other, right? That's why we have assigned a very high similarity score, a score of 5. Right? And this sentence we are assigning a similarity score of 0. Let us read these two sentences. The woman is playing the violin. The second sentence is the young lady enjoys listening to the guitar. Are they exactly similar? No, but they have some relatedness, some form of relatedness, right? So there is a woman in both of them, and they are listening to some musical instrument or playing some musical instrument, right? So there is some form of similarity. So maybe we can say that maybe we can assign 1. It's not completely similar, but also not completely dissimilar. Let us talk about this. The two boys on a couch are playing video games. The two boys are playing a video game. So what is the explanation here? The two sentences are mostly equivalent, but some unimportant details are differing. Something which is not important to define the meaning of this video game, or to define the meaning of this sentence, but that is missing in one of them, right? And what is that? Couch. It's not that important, right? But if it was there in the second sentence, then they would have been exactly similar. So this form of, or this kind of intelligence we want to add, or we want to kind of implement in our real world systems, right? In that can answer queries in real time. That is also very important. Okay. So what we can do as a as a student or as a researcher, what we can do, right? So maybe we should also contribute somewhere. Okay, so there has been a lot of research in NLP where people are kind of coming up with benchmarks. I don't know if you have heard about this term before. So people are coming up with benchmarks, right? So by benchmark, I mean, so this is a NLU benchmark. So by benchmark, I mean there is a repository which contains different tasks. If this is NLU benchmark, then different types of NLU tasks, right? We have talked about some types of NLU tasks. For that, you can download their data sets, right? You can read more about that task, and then there are some metrics against which you can compare. So metrics are like accuracy. I kind of come up with my model. I kind of come up with my machine learning model on this data set, and I have to compare my system with the existing systems for this accuracy metric, suppose, right? And then you upload your results on these benchmarks, and then you will be ranked against the other submissions. Okay, so this is what in general a benchmark means, and these days this is becoming very popular in NLP. Earlier it used to be very popular in computer vision community. Nowadays it is also becoming very popular in NLP, right? So for example, in case of this NLU benchmark, its name is GLUE. Its name is GLUE, and it has almost 11 different tasks, right? So again, I will not talk about all these tasks, and this came in 2019, very recent benchmark. So again, some popular things, some popular tasks that we have already talked about. One is this Quora question answer pairs. So you have Quora questions, and you just have to assign a label of 0 or 1, whether these two questions are same or not. Right? We have looked into this semantic textual similarity benchmark also. You have two sentences, and whether these two sentences are same or not, again there are different levels of similarity. Okay, then you have yes, there are this NLI. So natural language, this question NLI is about you. So you have a system, you are going to pass two inputs to this system. One is the question and one is the context, and the system has to come up with an answer, right? So this is this question NLI. This is the very simple scenario. So you have a question, you have a long paragraph, suppose, and the system has to kind of come up with an answer which is present in this paragraph, right? So this is the benchmark called GLUE, which was proposed, which came up in 2019, right? Within 6 months, yes. Yes, very good questions. So the first question is, the answer to the first question is here in this slide, the second slide that I was going to talk. Okay, so yes, whenever you kind of develop a new system, you download their data set. The data set is like splitted into train, test, and validation, and so on and so forth, right? You submit your results for the test one, right? And then according to how you have performed, your numbers will be updated in this kind of a tabular form, right? So what does this table says? There are these different teams. I've just taken a small snapshot. There are a huge number of teams that have participated for the GLUE benchmark, right? These are their names of the different models that they have proposed, right? And how these models are performing on different tasks that are present in the GLUE benchmark, right? So whenever you are developing a model which kind of can solve these problems, you can always experiment with this GLUE benchmark. See how it is performing on the GLUE benchmark. Whether, and all these models, if you see, this is from Microsoft, right? So most of the models that you see at the top ranks, you will find it from the organizations like Google, Microsoft, Baidu, and so on and so forth, right? Yes. Yes. No, so GLUE is just a repository, I would say, just a repository, right? Which has kind of a list of tasks, associated data sets and the associated metrics of how these tasks will be, how your model will be compared against other models, right? Just that, right? It's not a model, right? People have to submit the results of their models to this benchmark to get their numbers updated here, right? So what has happened, if you see here, within 6 months, of its launch, almost all numbers have saturated. We have reached the maximum, almost 97, 95, 96, 97, 98, 99, right? And it becomes so saturated that they have to come up with the advanced version of the glue, right, with more difficult tasks. They call it as super glue, right? So they call it as a super glue, and it has very difficult. They thought that whatever they are kind of coming up in the next 6 months, it has very challenging NLP tasks. That's what their impression was, right? Again, what has happened? Again, same things, right? You have some tasks here which look like very difficult. You have some data to download for each task, for which you can train your model and test it on their data sets. And these are some metrics, again, against which you can compare your model with the existing models. Now you see the results. It is also saturated within 1 year. Right. So NLU, if you talk about, at least on paper, everything is saturated. In real scenarios, I have showed you the results for Amazon. Right. In real scenarios, they don't perform well. But at least for these type of data sets, they are performing very well. If you see here, it is almost saturated. The super glue is also saturated. Right. So you can always come up with your own model, versions of your model. You can test it on this, but more likely you are not going to pass these numbers. You will kind of land up around these numbers only. At least, yeah. Why I'm saying not more than these numbers? The reason is the models that you're seeing here are being created by very well-known research groups which have unlimited amount of GPU resources, right? Which is usually not kind of applicable in the case of research institutes, right? So it is usually not possible to beat these numbers. You will land up around similar, but not more than that. Okay, but you can always try on these benchmarks. Great. Okay, fine. So I was just talking about NLU. We have looked into some NLU data sets. We have looked into some NLU benchmarks, and we have talked about glue and super glue, right? We have seen the problems with these also. Okay, let's talk about NLG, right? NLG, I described it as what? We want to generate a natural language text. Okay, and machine translation is one of such examples. So by a machine translation, the idea is simple. You have a source text in one language, you pass it through a machine translation system, and it translates that to some other language, Hindi to English, or English to Gujarati, English to this and that, and so on. Right. Okay. So I have not answered one of your the second question, right? How does these systems perform on other languages other than English, right? So they perform very poor. They perform very poor, especially on Indian languages, all Indian languages. I will show you. I will show you. Yeah. Right. So I will show you a very nice example from their own system. So, okay. So one of the NLG task is natural language processing. Okay. So not natural language, machine translation, right? So given a source language text, I want to convert it, or I want to translate into some third language or second language, right? So what I've done is this, that I have given my source text in Hindi, and I have asked Google Translate to translate it into English, into Hindi, right? So the source text is in English, and I have asked it to translate it into Hindi, right? Very simple task. Okay. So if you, I don't know if you have seen it before, maybe 5 years before, you have to specify what is your source language and what is your target language, right? Nowadays, it automatically detects. Given this text, it is more likely to be a Hindi text, or it is more likely to be a English text, and then you can specify in what would be your intended output language, right? So in this case, it has detected it as a English, and I have asked Google to convert this into Hindi. Do you think it is the correct translation? People who know Hindi, at least. People who don't know, it's fine. This looks like a correct translation, even though you don't speak this, right? So you don't speak this, but at least this is a correct Hindi translation, right? Okay, so this is the English source text was, this is an introductory lecture in NLP for ACM IKDD summer school. या ACM IKDD समर स्कूल के लिए NLP में एक परिचयात्मक व्याख्यान है. This is the and this is like a perfect translation. Right? Let us see some more examples. Are you feeling down? Right? क्या आप नीचे महसूस कर रहे हैं? Right? So this is from the Google Translate, for which they are claiming that they have got 0% errors with zero short learning, right? That's what they are claiming. Okay, and this is a real world example. Okay, let's see some more. So this looks like a simple text. This looks like a simple text for Google to translate, right? And you can see the translations. Let us see some more complicated translations. Yes, read it. What is this source text? A song from a Hindi movie. Which Hindi movie? Rockstar. Okay, very good. Right. And do you think the translation is correct? Right. Which line is not correct? Why did the country die abroad? It's completely incorrect. And why do you think this? You are getting this out. Why do you think this is an incorrect output? Because Google Translate could not see the context in the previous sentences. Right. So it is kind of translating each sentence at one time, not looking at the previous context. It seems so. I don't know what is the problem, but this looks like a likely problem with the translation system of Google, right? And this Google Translate system is their best translation system, which they also kind of sell it to other organizations. Right. So I've just shown you what is the problem with processing Indian text. Right. A very simple Hindi sentence or English to Hindi, and a bit more complicated, not that complicated, right? But the context it could not capture. Okay, very good. So that was one task, machine translation and that is a part of natural language generation. So you are generating a new text. You're generating a new text given some text. Okay. Another less interesting task is the following, and that is called summarization. Okay. So what is summarization? You are given a very long document, a document which has say 2000 words or 10,000 words and so on and so forth, right? You want to create a very small summary of 50 words. A very small summary of 50 words, right? Task is called summarization, and in general it is called text summarization. Right. So you have this kind of source text, and maybe this is one of the possible summary. Just see if this looks like a possible correct summary. Just read the source text and maybe you can say this looks like a possible correct text summary. Okay. Yes. Yes, there are. So there are some more. So this is a very long document for which has been summarized here, right? So there are some more text which is here, which is not present at least in this slide, but yes, it does work. Okay. Now for GEM also, or for this NLG also, you have benchmarks. Right? You have benchmarks, and this benchmark, again, there are not many benchmarks for natural language generation, because natural language generation is considered to be a very difficult task. Right. So in NLU, systems have reached very good numbers, but in case of NLG, the performance is still below par. Okay. Yes, but so we define it based on the kind of output you are getting here. Right. So so if suppose your output is in the form of labels, we just call it as NLU. If your output is in some form of a natural text, then we call it as NLG. That's a very basic kind of, I would say, subjective distinction between the different tasks. Okay. Yes. Anyway, you have to understand it, then only you can answer it. Right. Yes. So in case of GEM, there are total 11 tasks, right? So maybe some of the tasks are this, like you want to produce a likely sentence which mentions all above source concepts. So you can give your system a set of keywords A, B, C, D, right? And the system should generate a text which should contain all these keywords. Maybe a story which contains all these actors, something like that, right? So this is one task. Another task could be related to, you have a news article and you want to summarize it. Again, a very popular NLG task, right? And if you see here, their leaderboard. So leaderboard means what? Leaderboard means different models which are doing good at what different ranks, right? So if you see their leaderboard for each data set, so these are different tasks. These are different tasks. They have listed down top 5 models, right? They have also listed on all the models, but this just contains the top 5 for each task, the top best 5 for each task, right? And if you see this MT5 here, MT5 is doing best, right? All the different versions of the MT5 is doing good. What is MT5? MT5 is one of the language model. I have not told you what is the language model. Again, consider it as a black box. It does something. It was created by Google. So most of the tools or most of the models, if you see for this task, are present here. So MT5 is successor of T5. So T5 was also from Google, MT5 is also from Google, right? And they are kind of doing exceptionally good for generation tasks, for many of these generation tasks, right? So this, at least this one T5 here is also, MT5 is here, right? And so on and so forth. Okay. Okay. But the good thing is that if you can create your own system, you can easily test that system against the existing baselines, right? And this is what we will do in our today's lab session, that we will teach you how you can pick one benchmark, download the data from there, pick the existing model. Suppose you have not created your own model, but at least you can test with the existing models, how you can run them, how you can kind of fine tune them, and how you can update this leaderboards with the numbers that you are getting, right? So we'll do that at least in today's lab session. Okay. So whatever we have done till now was part of how we are looking into NLP these days, right? So whenever you will go to an NLP conference, they will always say these days that is your task NLU or NLG, right? But this is not how we used to see NLP 10 years back. So what we used to do in, or like before, was these very basic NLP tasks, right? So these are mostly the older NLP, the traditional kind of NLP tasks. Okay, let us see what are the traditional NLP or the fundamental NLP tasks. Again, some of the tasks we again do these days, but not all. One of the very simple tasks that we do these days or at those times is called tokenization. Very basic task, right? So idea is the following. You are given an input. I am talking about tokenization today. What is this? What do you call this input? It is a sequence of what?
Sequence of words.
Sequence of words. Sequence of words. Sequence of characters. So the task of tokenization is the following. Given a sequence of characters, I want to segment it into sequence of tokens. I will kind of describe it again in the next lecture, where I will talk about different types of tokenization scheme, right? Just for time being, consider it as you have a black box system. You are passing a sequence of characters, and the black box system is kind of generating the sequence of words, right? I'm calling this process as tokenization. Right? Okay, we'll see why it is important, but this is the very important task in NLP, tokenization. Remember this theme, right? The second less popular task is called stop word removal. Some of the words in English or in Hindi or in Gujarati are very popular, but they don't have any meaning. What are those words? Words like prepositions. right? They are heavily used. Words like determiner, right? Pronouns, words that are heavily used, but they don't carry any meaning. So we can safely remove them in many of the tasks, right? And this is why these words are called stop words, right? So can we remove stop words? So for in this example, if suppose you are given this input, what is this input? This is a tokenized input. Remember this thing. This is a tokenized input. This is not the sequence of character. This is a sequence of tokens this time, right? Given this sequence of token, can we remove the stop words? What are the stop words in this sequence of tokens? I am about. These were the three stop words. I just removed them, right? What are we left with? These tokens. Talking tokenization today. Okay. Can we further process it? The third very popular task is called lemmatization or stemming. I will tell you the difference between in the next class, right? So this is called lemmatization, where you want to reduce a word into its base form. A word into its base form, right? So if you have sequence of tokens like talking, tokenization, and today, then you want to kind of convert them into talk, tokenize, and today. These are their base forms. What is the base form of is? What is the base form of is?
B.
B. The base form of is, are, is B. Right. So what we want to do is we just want to convert the tokens into their base forms. Why it is useful? Maybe we just want to reduce the size of our data set, right? And it can also help us in better searching, right? Because if your actual data contains a word tokenization and your search query has a word tokenize, then this document should ideally have been returned by your system, right? So in just order to kind of normalize everything, I will kind of lemmatize my query also. I will lemmatize my source documents also. So that everything is in the same form. Everything is in the base form. And then things are easy to kind of retrieve. Okay. Yes. Yes. It will bring. Yes, it will bring. We'll go through that example also. We'll talk about that. Okay, there is one more task. So we'll have some more fundamental tasks. There is one more task called part of speech tag, right? So part of speech tagging we have just seen when we have started this NLP lecture, right? So by part of speech, I mean, given a token, I want to assign its part of speech, whether this is a noun, verb, adjective, adverb, preposition, pronoun, and so on and so forth, right? This is very useful. We'll see where this is going to be useful in the subsequent lectures, right? But this is also one of the tasks. So talking is a verb. Tokenization is considered as noun. Today is considered as noun. This could be our expected output. Okay. One more fundamental task is NER, named entity recognition. So named entity recognition, again the same task. The idea is the following. There are some named entities or the classes of the named entities like person, country, organization, and so on and so forth, right? Given an input text, I want to assign the tokens its named entity, right? For example, in this text, I love India and its culture. India is a named entity. India is a named entity, right? And the name of this named entity is country. This is also going to be useful. We'll tell you where. But all these are the basic tasks that ideally you should have done to do something. I will talk about that, the basic NLP pipeline, right? But this is kind of important. And finally, what we want to do is we also want to generate these nice parse trees. Input is going to be this. I love India and its culture, and the parse tree is going to be look like this. So if you talk about the POS tracks were token specific, right? For each token, there will be one POS tag. For each token, there will be one POS tag. But different words can also be connected together, right? So for example, you have a noun phrase in your sentence. You can always have a noun phrase in your sentence. So noun phrase will contain multiple words, right? They have some relation with each other. You have a adjective which is modifying a noun. There will be an edge between that adjective verb to that noun verb, right? So these are called relations. So this parse tree is going to contain those edges, those relations, right? Again, this is going to be useful. We'll see where. Okay. So given all this information and different kind of tasks that we have seen so far, this is how the traditional NLP pipeline looks like in general, right? This might not be true always, but in general you can kind of define it like this. Stage 1 is simple. You just want to clean the data, right? In stage 2, you want to pre-process it using the fundamental tasks, the tasks that we have seen. Then maybe you want to generate a representation. I have not yet said what I mean by representation, but representation is something that you will use it. And then maybe you want to create a ML model to do some tasks, right? For example, in your case, maybe you want to create a sentiment tool, which kind of predicts what is the sentiment of a review, right? So you will pass this review sentence. You will first of all clean it. You will pre-process it using the fundamental task. Then maybe you will create some kind of a representation of that review task, a review sentence, and then you have a ML model. I hope you have seen logistic regression and other ML models, right? You pass that representation through this ML model, and this ML model will say whether this is positive or negative. Okay. So each stage we will get into like in details in the next lecture, the upcoming lecture that will start at 2. Okay, fine. So I will stop here. We'll again meet at 2. Right, so we'll meet at 2, right? Or 2:30? 2, right? So we'll again meet at 2, and I will resume it from here, the traditional NLP pipeline, right? So we'll see the different stages of this pipeline with example, and then we'll move directly to from traditional to the new kind of NLP that we are doing these days, right? And then we'll do some coding practice, and in the evening you are going to have a practice or a demo session of how you can train models, how you can update these benchmarks and so on. Okay, so that's all for today. Thank you. Any questions from the online people? No? Okay, great. Thanks.